In today's lesson, we are going to be looking at one variable analysis, and specifically we're going to be looking at measures of central tendency. So what are measures of central tendency? Well, they are measures, or they are values or statistics that commonly or that refer to the central or common value in a data set. And these can be sometimes classified as summary statistics, as they basically summarize a data set or a set of data. And generally, they represent the middle of a set of numbers. So the measures of central tendency, again, talk about the central or common value, or representing what the middle of your data is. There are three types of measures of central tendency, or there are three values or statistics that we are going to look at. And those are mean, median, and mode. So you may have heard of these before. The first one is the mean. And mean is just another word for average. So we've seen or we've looked at average before, or hopefully you've looked at that in the past. But basically, to calculate the average, we are calculating it by adding up all the numbers in the data set and dividing by the total number of numbers. And basically, this value represents all the values in the data set because they're all being included. Now, we have two different formulas we can see up at the top here. Essentially, they represent the exact same thing, which again is adding up all the values and dividing by how many data points you have. The two differences are, though, one is looking at a population. So if you're looking at an entire population of data, or in terms of sampling, you're looking at the entire population, which is everyone. Or the other one is looking at a sample. Again, the steps to solve for it aren't any different. It's still the exact same thing. We just have different variables or symbols used in our notation. So for a population mean, we have the Greek letter mu, which again just represents the mean, which is the sum of, which is our sigma, x, which is our data points. So adding up all our data points, dividing by n, which is the total number of data. Total number of data points. The second one is the exact same thing, again, just different notation, because it's going to represent a sample. So here, the symbol to represent the mean for a sample is what we call x bar, x with a line across from it. Again, it's still the same thing, the sum of the data points divided by the total number of data points in the sample. So again, same idea, just different values. Or different variables, sorry. So again, we can see in this comic as well, sometimes using the mean can be a little bit misleading depending on what we look at. Because it's involving every single value, right, we can misrepresent some things. So the example here, what would my starting salary be? And I'll put it to you this way, our average starting salary is $80,000. However, if we look at the actual breakdown of all of the salaries, we can see that it's $80,000 because there is one extremely high value, right? And that overpowers or changes the mean or the average when the rest of them are lower. So even though the average is $80,000, no one is actually earning that. So again, just things to consider when you're looking at the mean. Do you have any extremely large or extremely small values that could be affecting your mean? So in our first example, we're going to look at kind of a large, not a large data set, but just large values. We're going to be looking at the population for the 10 countries below. So I would consider this a sample. So I'm going to be using x bar equals the sum of x divided by lowercase n, or the number of points. So the sum of basically means I'm adding up all of my values or all of my data points. So in this case, I'm adding up all of the populations for the 10 countries I see here. So we have 35, 5, 8, 7, 7, 9, 3, plus, and then so on, all the way to the last one, 92,423,338. We're going to divide that by the total number of data points. In this case, because I'm using 10 countries, I'm going to divide by 10. And in this case, to find my sum, again, you just have to add all those up. And you should get 2,421,604,126 divided by 10. So we get 242,160,000. So basically we just shift our decimal place over 1. So that is our mean or our average population between these 10 countries. Now looking at that, you can say, well, that's a pretty large average, but if you take a look at some of the countries we used, we have China in there, which is quite large, right? That's at 1 billion already. We have the USA, which is at 320 million roughly. And we have a lot of other countries that are smaller. So those larger countries do kind of overpower or impact our average. As well, along with using kind of this formula, we can also use Google Sheets. And depending on the numbers or the amount of data points we have, it's really beneficial to use Excel or Google Sheets using the formulas that we do have. So for example, if I go to my table, you zoom in here, so we can see that I have my countries, I have the populations already entered. The easiest way, if I want to find the mean or the average, if I type equals, I do already have it coming up, but if I just start to type in average, I can see that it's there. Average, numerical average value, ignoring text, that's the one we want. And then we're going to highlight or select all of our points. So we should be familiar with this process. Oops. Let me just change that to 11. We should be familiar with this process. We hit equals or enter, and there we have the exact same mean or average population that we had when we calculated it by hand. They've rounded it, again, same idea, but a lot easier using Google Sheets. So that is our mean or our average population for these 10 countries. Coming back to our notes, the other, or one of the other measures of central tendency in this case would be the median. In this case, the median is the data point that lies in the middle of the data set when ordered. Again, that's a key thing, when ordered. We order it from lowest to highest as well. If we have an odd number of data points or values, the median is going to be the exact middle value. So when you line them up in order, it's going to be the middle value. When n, or the number of data points, is even, the median is going to be the average of the two middle numbers. And this value is also referred to as the 50th percentile. So basically at that point it means that 50% of your data points are below or above that value. So again, why should I invest? Just another misrepresentation of how median can be used. Why should I invest with you? Well, not to brag, but my fund has a median gain of 8% per year. Looking at the actual gains, yes, you've ordered it from lowest to highest, or you could order it based on the years, and we can see that the middle value is not quite a good representation of the actual gains or the actual performance. So again, the median is the middle value. So we're going to go back to our table, and we are going to determine the median for the same 10 countries. So again, the first thing we want to do is order them from lowest or from least to greatest. So in this case, the lowest population here is actually Canada, so we're going to put 1. 2 would be France, 3 is the UK, 4 is Germany, 5 is Vietnam, 6 is Mexico, 7 is Japan, 8 is Russia, 9 is USA, and 10 is China. So by ordering them, I'm going to find the middle value. Because it's an even number, because my n equals 10, that means I'm going to have to find the middle or the mean or the average of our two middle numbers. And if I count to the middle, my two middle numbers in this case will be 5 and 6. So I need to take the average of that, of those two numbers. So 92,423,338 plus 125,385,833 divided by 2. Give me 1 second to calculate it. We get a median value of 108,904,585.5. So that is our median. That's how we would do it by hand. We would order it from least to greatest, count to the middle. In this case, because there's an even number, I need to take the average or the mean of my two middle values. However, I can again also do this using Google Sheets. So I have again my population, or I have all my data values entered. I'm just going to label my median, and again on our note we had the formula equals and then median, and because I've already entered a previous one, it does give me a suggestion based on what I've already done. I'm just going to go through and do the full thing. Click on median, highlight the data values that I want. So from USA to from Canada down to Vietnam, and hit enter. And again, we can see we get the exact same value that we calculated by hand. Again, just they've rounded it. So that is our median or middle value of our population. What we're going to do now is just kind of go through another example, but we're going to throw in the population for Spain into our table. So that's going to change it up a bit, and then we're going to calculate the median from there. So I've added Spain in here in gray, and what we're going to do is, again, we're going to go through and order them. So again, Canada's 1, Spain is now 2, France is 3, UK is 4, 5 is Germany, 6 is Vietnam, 7, 8, 9, 10, and 11. So here we have an odd number of data points. So because we have an odd number of data points, I just need to count to the middle. So in this case, the middle value, if I go 1, 2, 3, 4, 5, 6, if I go backwards, 1, 2, 3, 4, 5, 6. So 6 ends up being my middle value. So in this case, I don't have to actually calculate anything. I just find the middle value. The median is 92,423,338. So again, very easy to calculate the median when we have an odd number of data points. Again, we can use the exact same thing with Google Sheets without regard for ordering or counting it. So I'm going to copy in Spain's values. Let's just move these down a bit. So I'm just going to delete this and restart. So again, I'm looking for the median. I'm going to go highlight all of my values, hit enter, and we can see that it's the exact value that Vietnam was, because Vietnam, or that data point, was our middle value. So again, Google Sheets, using that formula, orders it for us. We don't have to worry about it. So again, very helpful tool. Finally, the last one is the mode. And the mode is the data point that shows up the most, or the value that shows up the most. If all the data points are unique, then there is no mode, and you would state no mode. You would not state 0, because if we see a mode of 0, that means we're assuming that 0 is the value that comes up the most. If there is no mode, we specifically have to state no mode. If there is a tie between the number of points that share the same value, all values that are tied or that have that highest amount are considered the mode. Right, so you can have multiple values or multiple points that are considered the mode. Again, this is most useful when we're looking at nominal categorical data. So nominal categorical data, just some terms we haven't seen before. Nominal just basically means numbers, and categorical just means categories. So basically, if we're looking at different categories, so again, looking at populations or looking at countries, that's the category, and our number is the population in each. So that does work as well. And again, we use mode when what matters most is the data that comes up the most. So that might not be in all cases, right? Depending, maybe you're looking at shoe sizes, right? That's a nominal categorical data. Shoe size is something that where the largest number that occurs is the best, or what we're most after in terms of saying purchasing stock or inventories, things like that. Modal interval is something that we can use when some of our values aren't very nice. So modal interval, the interval of data points that shows up the most. So again, it's very similar to the mode, except the difference here is that we have intervals of data rather than a specific value. And this is used if the data set is continuous or consists of many different discrete values. So continuous would be things like time, anything in terms of measurement, things like that. All right, so we did talk about this briefly in population or probability distributions, continuous data, the things that we can measure, time, weight, height, things like that. So those values aren't going to be stuck to a certain category, or there's not going to be fixed values. So there's not, the chances are of things or the same value coming up multiple times is very unlikely. Same with different discrete values like population. It's very unlikely that you're going to find countries that have the exact same population. So using a modal interval may be a little bit more beneficial when looking at these types of values. So again, just another way of looking at how mode can be misconstrued. Right? So how are you doing on your tests? My modal category is 70 to 80%. So you can see on his actual scores, he has they have two tests that are in the 70s, but then they have tests in all the lower score categories, but they're only one apiece. So he's saying don't ask about the mean, because that would give you a better reflection, in this case, on their actual test score. So again, we can use Google Sheets. We've gone through that a couple times to look at mean, median, and mode, or just at least mean and median. I'm going to go back and show you how you can use mode in Google Sheets. So if all the values were discrete, they were nice values, it was a nominal and categorical, we could do something as simple as equals mode, and we do have that come up, again, most commonly occurring value. So I can click that, highlight all my data points that I want, and hit enter, and here we get an NA. So that means a mode cannot, or that formula cannot produce a result. So that means there is no mode, right? Which makes sense, because we talked about there's not going to be a specific country or countries that have the exact same value. So in this case, it doesn't work, because again, our values, even though discrete, right, there's fixed values, you can't have half a person, it's very unlikely that they're going to have the exact same. So here, we would want to use the way of creating a histogram to create intervals. So I'm going to highlight all of my data that I'm looking at. I'm going to insert a chart. Zoom out a bit. So here, we've come up with a scatter plot, but I want to change that. So I'm going to scroll down, and it's under Other, and it's the one that says Histogram. So now I have a histogram, and I can see intervals. Right? So I have 0 to, I think it is 2800 or 280 million, then 280 million to 560 million, and then there's some gaps here, right? So that's pretty spaced out. We can definitely see which one occurs the most, or which interval occurs the most. But the thing is, when you're dealing with histograms, you want to make sure that the number of intervals that we're looking at is anywhere, usually around 10 intervals tends to be a good representation. If your interval is too big, if I made it from 0 to 100, from 0 to 1 billion, right, that would include almost everyone. So it doesn't give us a good representation of our actual data. So we want to make sure our intervals are in a nice spot. So it does take some kind of adjusting. To do that, you go to Customize, Histogram, and we're going to change the bucket size, or this is what we talk about, the interval size. So I'm going to change it to, let's say 50 million. So 50, 1, 2, 3, 1, 2, 3. So here I have a lot more, or a larger set of intervals, right? We can see down here 0 to 50,000 or 50 million, 50 million to 100 million, 100 million to 150 million, and so on. It's okay that there's gaps, but it does give us a little bit better representation of the modal interval. So we can see here, going back to our table now, or our chart, we can see that the modal interval, based off of this interval size, is from 50 million to 100 million. Right, so the mode, I would just say 50 million to 100 million, and we have 4 countries. So that one you may have to just type in There's not really a formula for it, but you can use the histogram to make it a little bit easier to represent, and it automatically creates those intervals for you and sorts the data so you don't have to. So again, just how you can use, again, Google Sheets to look at all three different measures of central tendency. So again, we talked about the average formula, we talked about the median formula, we talked about the mode formula, and again, I would say for bucket, just put a little note. Say at least 10 intervals. But again, you do have to be careful. You don't want to have too many at the same time, because then it would just space everything out where it would just be one for everything. So you do have to kind of play around with that a bit. Next, we're going to look at a couple different examples of looking at the mean. So different situations that you may come across. So in this example, a pair of dice is rolled 100 times and the sum recorded. Determine the central tendencies. So here we have the sum and we have the frequency, similar to what we've done before in probability. This one's going to be a little bit different, because when I'm calculating my mean, I have to take into account some other factors. Because I have a frequency, this is going to be very similar to what we would have done with kind of our weighted means that we looked at before. But if I want to find the mean, I'm going to consider this my population. So again, it's the sum of x divided by n. But because it's broken into a frequency chart, that means the value of 2 occurred 3 times. So this would be the same thing as saying 2 plus 2 plus 2. And then for 3, we have 3 plus 3 plus 3 plus 3 4 times. Because again, if we kind of color code this, 2 came up 3 times, 3 came up 4 times, and so on. To make this a little bit easier on ourselves, right, I can still find the mean, but it's going to be the sum of x times the frequency divided by the total number. So here I would do 2 times 3 plus 3 times 4 plus 4 times 7 plus 5 times 13, and so on, all the way down to 12 times 4. So again, just making it a little bit easier on myself. And I'm going to divide by the total number, which in this case, if I add up all the frequencies, I should find that there are 100 trials. And when I go through to calculate my mean, I should get an average of 7.21. To find the median, again, I could go through and list all of these values. However, I know that based on the fact that there's 100 data points, the middle one would have to be at 50 and 51. Again, because of the average, or because it's an even number, I need to look at the 2 middle numbers. So in this case, the 2 middle numbers would be 50 and 51. So I can go through the frequency. Because it's already kind of ordered based off of this structure, I know that 50 and 51, so 3 and 4 is 7, plus another 7 is 14, then 13 is 27, 42. So from 42 to 56 is going to be in this block. So that means for the median, the data point 50 plus the data point 51 divided by 2 will give me my mean. In this case, they both happen to be 7, or sorry, my median. So 7 plus 7 divided by 2 just equals 7. So my median is 7. Lastly, for our mode, this one is really easy. Let me use a different color. For a mode, this one's really easy because I can just look through and see which one occurs the most. Oh, but I think I have a typo. This should actually be 15. So if I look at the mode with that quick typo adjustment, the mode would be 6 because it occurs the most. So again, that's just kind of how we would work through when we're dealing with a frequency table. Example 4, here we're going to look at, well, what happens when I'm dealing with values that are already grouped into intervals. So this is a little bit different. So it's not like the intervals we looked at with the histogram. This is where we have intervals already set out as our data points. So what we use here is we use the same idea. Because of the frequency, we are going to use some form of the sum of the data point times the frequency divided by n. However, I don't have a specific data point because my data points are intervals, as we can see over here. So the trick is, or the process is, we are going to use the midpoint. So what is the midpoint of my interval? So in this case, 50 plus 0 divided by 2 equals 25. So that means my actual formula is going to be the midpoint times the frequency. So here I have 25 times 0 plus the midpoint of the second one, so 50 plus 100 divided by 2 equals 75. Plus 150 plus 100 divided by 2, 125. So 125 is my midpoint times the frequency, which is 3. And then 150 plus 200 divided by 2, which equals 175. So 175 times 10. All divided by the total number of data points, which in this case I can add up the frequency, so it would be 15. This means that my mean would be 151.6. To find the median, so to find the median, I want to find the middle value. Because I have 15 values, that means that the middle value is just going to be the only one I take. So I have to figure out what is the middle value. Well, if I divide 15 by 2, I get 7.5, which I can't get an exact value for because I don't have that actual position, but I would just round that up to 8. So I'm looking for the 8th position. So if I look at this situation, the middle value would have to be in the 8th spot. So looking at the frequency, there are 0 in the first, 2 positions in the second interval, then 3, so we're at a total of 5. So the first 5 positions are down in these 3 intervals, and then lastly, the next 10. So position 6 to 15 would be in the last interval, so that means position 8 is in there. So that means my median has to be 175, because again, I'm still using that midpoint to approximate. Finally, for the mode, I could talk about the modal interval, or if I wanted to approximate, I would say again 175, because that's the one that comes up the most. Or I could say the interval of 150 to 200, similar to what we've looked at previously with the modal intervals in Google Sheets. The last example we're going to look at is looking at the weighted mean. And we've done this before when we've looked at kind of the weighted average. So we've looked at this before. This is very similar to kind of like the expected value, almost. The difference here is that we are still going to be dividing by the total number or the total weight. So we do have a formula to figure out the weighted mean. So we are adding up the sum of the data points multiplied by their weight divided by the sum of the weights. So when we did expected value, our sum of our weights would be the sum of all the probabilities, which would have been 1. So that's why we used this formula before in a similar fashion without really kind of seeing it like this. So if I'm looking at this example, I want to determine the student's current mark or their weighted mean. So I see, or I have to add up all of their values multiplied by the weight. So 78 times 10 plus 85 times 10 plus 66 times 10 plus 80 times 10 plus 70 times 40. Let me just move this down a bit. Then I'm going to divide all of that by the sum of all the weights that I've looked at. So in this case, 10 plus 10 plus 10 plus 10 plus 40. We're basically saying this is 80%. So the average rate now, when I add up all my parts, divide, I should get 73.62%, or you could argue 74%. So that means the rate now, their current mark is 74%, because that is factoring into account the different weights. So the main thing from this is, again, looking at the different measures of central tendency, mean, median, and mode, and understanding what they represent. From the comics, hopefully we saw how those values can be misrepresented based on the data we have. And then finally, making sure that we can use Google Sheets and the formulas and the histograms to calculate the mean, median, and mode, because it does make the sometimes tedious process a lot easier.